This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data with Gen AI. Friends, in previous session we were discussing about the transformer internals, like what exactly is being happening inside the transformer architecture so that we are able to get the desired outcome. We are having some new faces over here, Neha and I think Gaurav, who are attending this session as the first time. So to them, like we are going through with the Gen AI, and over here we are trying to learn how the things are happening with Gen AI, generative AI basically. Okay, we are having a lot of portals. At this moment, say ChatGPT is there, Grok is there, DeepSeek is there. So how these particular portals are working and they are able to provide the information uh, like the humans are providing. So in order to deep down into these particular things and to understand it in these particular sessions in a better way, what I request you to please go through with our previous sessions. I will share the recordings and all, so go through those particular sessions and then you will be having the better understanding. We are having only 4 to 5 sessions at this moment, and it will not take much time in order to go through with those particular sessions. Now I'm coming back to the point, the transformer architecture. So inside the Gen AI, the backbone for Gen AI is nothing but the transformer, and we were discussing uh, about its internal. So once we are talking about the transformer architecture, say we are passing the information as sentences. So those particular sentences will be then converted into tokens. Let me write it down. Just give me a minute. Just give me a second. Okay, transformer internals. And we are passing the information in terms of sentences. Then these particular sentences are converted into what? Tokens. Then we will be having the positional embedding and all. Then attention mechanism is there. And what we do in attention mechanism? What exactly is being happening inside the attention mechanism, friends? Can someone tell me? I thought I was speaking on mute. Huh? Anybody? Rohit, Shivam, Swati, Vijay. What is being happening inside the attention mechanism? Guys, are you with me? Are you able to hear me? Are you able
Yes,
to
sir,
hear
we are
me?
able to hear you. Like I missed last Sunday session. Sorry for that. So I missed this topic.
So in tension mechanism, whatever we are giving the input, so it will try to improve that context part or something, adding some good to help the context.
Mm-hmm. So attention, huh? So attention is nothing but retaining the context, huh? Retaining the context. The context. Huh? Over here, we are trying to retain the context. I have quoted one example. Say, I'm running an organization and I'm going out for running. So two words are there, running, but both of these two words are having different meaning into different situation. Okay, so this is the task of attention mechanism to retain the context. If like I'm saying I'm on running an organization and then I want to have some prediction from the Gen AI model, then how it will be able to predict? It will be able to predict because it has retained the context from the previous line. Okay, and what will be the context length, that will depends upon model to model. These are certain configurations that we need to set. Okay, and based upon the configurations and all, we will be able to get the outcome. Okay, so attention is nothing but retaining the context, and MLP, that is multi layer perceptron. Okay, we used to say feed forward neural network. Let me mention over here, feed forward neural networks. Okay, so over here the third party, or you can say external information, is being utilized. Info uses or tries to know the fact. Know the facts. Okay, so over here whatever the outcome that we got, so it will be vetted with the help of the multi layer perceptrons. That is nothing but the neural network. It will be passed again and again with the different neural networks, so that we will be having the actual information. You can think in this particular way. It will be uh, say if we are asking something to the Gen AI model, okay, how it will be able to provide the correct answer? Definitely, it is going to take certain references. Okay, those references are nothing but comes through the multi-layer perceptrons. Okay, so over here the neural networks is utilized in order to get the correct outcome, and over here we are having, say, feedback mechanism, positive, negative. Those particular things will be applied to the outcome in order to get the correct outcome, and finally we will be able to predict the next word or next sentence, whatever. Okay, so this is nothing but what exactly is being happening inside the uh, transformers. But uh, what I have explained, like the tokens which are given, these particular tokens are talking to each other, and they will be having the dependency, and based upon those particular dependency we are going to set certain weights. It is not like, say, uh, we are having, you can say, a stuff that is providing the outcome, but over here uh, things are mathematically aligned. because of that only we are able to get the outcome, and how that mathematics is being applied, that's we are going to learn in this particular session. I will be going through with one document. Let me share. So over here I'm having one document. Okay, word embedding demo tutorial. So with the help of this particular document, I will show you how the weights are given or modified uh, for each and every token. You know, whatever is there, say if I'm talking about the GPT-4 model, GPT-4, that is nothing but the model for the chat GPT. GPT-4, this is the foundation model for chat GPT. Okay, so over here the vocab size is 50K. Okay, vocab size 50K, and the dimension, or you can say the features, dimension is 12288, 12,000 uh, 12,288 dimensions. It is working into this much of dimension. And if we are talking about the BERT model from the Google, okay, that is having 768 dimensions. What is the meaning of this, that we will be going to learn now. Okay, now you can think in this particular way, like say we are having some data. Okay, say man, we are going to represent some data. Don't go through with the royalty at this moment, okay. So we are having, say, certain data, and we're trying to represent it mathematically. Say man, the gender one is there, boy is also gender one, and once this is with respect to the access, say, onto the uh, like boy onto the axis to, say if we are plotting it, just have a look. Okay, so you can say the gender is this particular graph, this particular axis, and age is this particular axis. So we are having boy, and the value of, say, boy at gender axis is 1, and on age axis is 2. Okay, then the girl is there, and with respect to the girl, the onto the gender axis the value is 9, and onto the age axis the value is, say, 2. Okay, so over here we are having say, one similarity between boy and girl, that like onto the age axis both are having 2 values. Uh, both of these are on 2. Okay, and then like once the age is increased, so the boy became man, and onto the age axis the value is 7, and for the woman the age, onto the age axis the value is 7, and onto the gender axis it is remain same. So if we want to represent it mathematically, so it will look like, say, it will look like this. Say man 1 and 7. Okay, and boy 1 and 2, girl that is 9 and 2. Over here just have a look, so girl 9 and 2, woman then 9 and 7. Okay, so woman 9 and 7. So over here we are able to represent it in terms of mathematics, and this is nothing but 2D dimension. This is nothing but uh, 2 dimensions, like we are having x-axis and y-axis. Clear so far to everyone? We are representing the information with the help of 2 dimension 2D model. Is it clear to everyone?
Yeah.
Okay. Now, say if we are adding some more, you can say, data. Okay, so this is the representation of man, woman, boy, and girl. Now if we are adding some more, you can say, features, say infant, child, and adult. So infant, with respect to this, like the boy and the girl can be infant. We used to pronounce infant to boy and girl. So say onto the gender axis the value is 5, and onto the age axis, say infant is having less age than boy and girl, so we used to mention say 1. So 1 and 5 is the representation of infant, huh? Then child is there, then adult is there. So with respect to this, we will be having the representation, and we will able to denote it mathematically, huh? Say the child is there 5 and 2, so this is onto the age axis and this is onto the gender axis. Then the girl is there, okay, we have gone through with girl. Then infant is there, then that is nothing but 5 and 1. And in the same fashion, we will be having 7 and 5 for the adult. Now if the grandfather or grandmother is there, then what will be the value? So with grandfather will be say onto the gender axis it will be 1, and onto the age axis it will be say 9. So grandfather 1 and 9. So this is nothing but the mathematical 2D representation of grandfather, once we are having say these particular features, so at this moment we are talking about two features, gender and age. Okay, and with the help of gender and age we are denoting the different, you can say say boy, different categories, boy, girl, man, woman, okay. So we are denoting it, now
So
say
just one more.
another. Yes.
So, yeah, sorry. So basically, this adult, child, and infant, we have provided number five. That on the number five, it will be kind of a general neutral. It can be boy or it can be girl. And then on the y-axis, we are representing the age. That infant is 1 year age, child is 2 year age, and so on. Correct?
No, this is not like you can think uh, this is not with respect to age, say 2 years. This is not in years, but this is the age, right? Don't get confused with the help of this. Say this is 1 year, 2 year. You can take it in this particular way. Like say you can categorize say 0 to 5. We are
Uh,
representing say right.
exactly. It can be group of the age also. But
Yes,
it is
yes,
representing group of age, and line number five is representing that it is, I would say, means it is a kind of a neutral thing. It
yes,
can be
yes,
boy
yes.
or it
Neutral.
can be
It
girl.
can be boy, it can be girl.
Okay, okay.
Okay. So this is the mathematical representation based upon the data set what we are having. Now there are certain other things we can add, teenager, grandparent, grandmother. So those particular things can be added. But say if we are going to add another, you can say thing, that is the royalty. So say king, queen, and prince and princess. But every man and woman can't be king or queen. Every boy cannot be like the prince, or every girl can't be princess. You can take it in this particular way. So what we are trying to add, we are trying to add the third dimension over here, and with respect to the third dimension what it will be say the royalty, okay. Royalty is the third dimension what we are going to add over here, okay. The royalty has been added, age, gender, and the royalty, okay. Now you can take it in this particular way, like the boy is there, and boy is, you can say, closer to prince, and the girl is closer to say princess, and the woman is closer to queen, and the man is closer to say king. Okay, so you can, I have the representation of this, you can take in this you can take it in this particular way. Like I have represented uh, the values what I'm having in this particular Excel. So I have represented it in 3D model. So this is the 3D model what you are able to see over here, like say age, gender, and royalty. So what is the meaning of this? Say girl, if we are talking about girl, girl is having say 9 onto the x-axis, okay, and 9 on x-axis. So girl is say this is girl, and onto the age axis, onto the gender axis, onto the gender axis. So this is this is the, okay, this is the gender axis, Okay, basically, and over here the value of x is 9, y is 2, and z is 1. Okay, you can think in this particular way. Girl is 9 onto the gender axis, 2 onto the age axis, and 1 is onto the royalty. Okay, 1 is onto the royalty. Then the princess is there. Princess, like 9, 2, and 8. Okay, so let me try to girl. And you will be able to see, say, girl will become princess. So 9 2 over here we are having like two features are similar. Okay, one is different. That is the royalty. Okay, in the same fashion, if we are talking about the boy, so with respect to the boy, like we are having two similar features and one is the different one. Okay, one is two similar features are there, one is the different one. The same thing we will be able to see over here. 1 to 1, this is boy, and 1 to 8, this is nothing but the prince. Right. Then king 188 and man 171. Okay, 188 and 171. So basically, like over here, a little bit you can say more age is given to king. This is just to, you can say, denote, like we have heard so many stories about the kings and all. So no such, you can say, major difference is there, but the from the age perspective, a little bit age is more age is, or more reference is given to king with respect to man and woman. Over here onto the age axis, like we are having 7 7, but onto the age axis for the king it is 8. We can keep it 7 as well, but like just for the the understanding perspective, we have taken it as 8. So what I want to say over here is, like, once we are trying to add more features, okay, more features, then the dimension will keep on adding. Say if you want to add some more features over here, say over here, like it has mentioned, say if you want to add certain word, you can say car, plane, okay, or vehicle. If you want to add over here as a feature, so that will come into the fourth dimension. If you are willing to add say another feature, say uh, say home. Okay, so home, so we can have palace, we can have house, we can have flats. Okay, so home is nothing but, or you can say uh, place to live. Place to live. So man, woman, boy, girl, probably we can have different categories, flats, palace. Okay, so that will come in into the say fifth dimension. So so with respect to the words that we are adding, so these particular dimensions will keep on adding up. Over here I tried to represent it with first with the 2D, and now we are representing it with the 3D model. But this representation is fine. Mathematically we are able to see. Okay, but what is the significance of this? Okay, what is the significance of these particular numbers what we are able to see over here? Okay, so the significance what we are trying to learn at this moment. Now on to this particular 3D plane, what we are able to see, say girl is there, then a girl will become, say, woman, and say prince is there, princess is there. Over here, like we can we can find the distance. So what I want to say, inside the transformer architecture, the tokens talk to each others. And what is the meaning of talking? The meaning of talking is that, like, there is a relationship between these particular tokens. I'm trying to calculate the relationship based upon the distance. Okay. So over here, if I'm trying to calculate the distance, say I'm having one word over here. I'm having one word. Uh, say if okay, say man is to king as woman is to. So I'm having this particular word. Let me mention over here. Okay, I'm having this particular word. Man is to king and woman is to what? So I need to calculate. I just want to predict it with the help of this particular given mechanism, this particular given data. Now, say man is to king. So what I need to do, I need to find out the values for man and the values for king. Okay. So with respect to our matrix, the value for man is say 171 and value for king is 188. Okay. So what I will do, I will say deduct it, and then whatever the outcome I will add to the woman, and then whatever the outcome I will be having, that will be closer to my
Princess.
expectation. Yes.
Yeah, yeah, that will be closest to the princess, our result. Yeah.
Yes, so let me try to do it. So over here, what is the outcome if I will do this, say king minus man. Okay, minus man. Okay, so what will be the outcome? It will be
0,
say
1,
0, 1
7.
and 7. Okay, and what is the value for woman?
Mm,
9, 7 and 1. Okay,
mm.
so what I will do, I will add it. So what I will got 9, 8 and 8. Okay, 9 and 9, 8 and 8. So 9, 8 and 8. So so this is closer to what?
Queen.
This is closer to queen. Okay, so what I will be able to get, I will be able to get queen. Like say man is to king, woman is to queen. So I'm able to predict with the help of mathematics. So over here, uh, in order to calculate the distance, we are having certain formulas. Okay, Euclidean distance is the formula that I can utilize in order to calculate the distance between the given, you can say, uh, variables. Now
Mm-hmm.
over here, say man is closer to boy is closer to man, girl is closer to woman. Okay, so if I want to calculate the distance, so Euclidean distance, just have a look over here. Uh, over here, I tried to calculate the distance. Say, can you calculate the distance between boys and boy to girl and boy to woman? Okay, boy to girl and boy to woman. Okay, so over here, this is the simple formula. Okay, say we are having certain values onto the with respect to boy and girl. I will do the minus and then then square it, and then I will calculate the square root, and with respect to that I will be able to calculate the distance. Now say boy to girl is having distance this 8, and the boy to woman is having this particular distance over here. Probably like there is inside this particular example, certain, you can say, another formula is being utilized. So the distance is coming 8 and 11.75. Okay, so but the main thing is that like boy is near to girl, and uh, with respect to the woman. Okay, so the distance between the boy and girl is less compared to the boy and queen. Okay, right? So are you able to get the distance calculation?
Yes.
Now, okay, now now you need to think at this moment. Okay, so we are having, at this moment we are trying to to visualize the things in 3 dimension. Okay, and with respect to the 3 dimensions, 3D models, we are trying to calculate the distance, and with respect to the calculated distance, I'm able to see, based upon the distance only, I'm able to see that if man is king, then woman will be queen only. Okay, I'm able to predict the next word, right? Based upon what? Based upon the distance only, right? In the same fashion, like I will be able to do the predictions if in boy is there, then it will it will be closer to man, instead of, you can say, uh, you can say woman, or a boy will be closer to prince instead of say princess. Okay, so boy definitely will become prince and prince will become the king. So the distance between the boy and the king will be more compared to prince and king.
But how it is
Okay,
designed overall means how it is coming.
so what over here we are representing it with respect to, let me try to mention over here. So over here we are representing the informations or data into 3 dimension, 3 dimension. But if we are having vocab size, say 50K, that is there in GPT-4. GPT-4 is having 50K vocab size.
Yes.
Okay, okay. So if we are having 50K words or 50K tokens, what I can say, then what I need to have the major dimension, huge dimension, in order to represent all of these 50K words, right? All of these particular 50K words will be represented, uh, and huge dimension is required. So for GPT-4, 12288 is the dimension. Now like if I'm having say man, okay, so man will be represented, it will be having say, it will be having 12288 values with respect to each and every, you can say for with respect to say gender, age, okay, royalty. Okay, so these are nothing but dimension, and this particular man will be having 12288 values. Okay, so say 1 is there, 2 is there, I'm taking hypothetically, 3 is there, 4 is there, 4 is there, 5 is there. So the gender and this man will be having these particular values, and then man and gender, based upon these particular values with respect to dimensions, then certain weight will be there, distance, let's take distance as a weight as at this moment. However, like certain more things will be done. So say gender, what gender, but gender is not this, gender is man only. Okay, is royalty, and then say living things.
Mm. Mm.
Okay, well, I'm just mentioning it. Okay,
Yeah.
uh, fruit. Okay, so there may be different, you can say, dimensions.
Mm.
Okay, but with respect to the each and you can say every dimension, we will be having, it will be having 1 2 2 8 representation, 1 2 2 8. I'm talking about three you can say things at this moment over here, but it will be, the man will be having 1 2 2 8 values, and
Okay.
the main motto is to assign, is to have the weights with respect to each and uh, every you can say value onto the 1 2 2 8 dimension. You can take say distance, okay, say man to age is having say 0 point this much distance, okay, and this man to royalty is having say 0.999 distance, okay. I'm saying distance at this moment, but like it will be the weight, okay.
Yeah.
Now once we are talking, once like we will be having the word say man is playing,
Mhm.
okay, and we are having uh, say kabaddi over here somewhere, or say cricket is there, and
Mhm.
then that particular you can say word man playing, and then okay, so man and playing, there is you can say a relationship, and playing with playing man, and then kabaddi will be having, or cricket will be having certain distance, or you can say weight. So based upon that, say man playing, we will be having say cricket, kabaddi, we will be having say different probabilities,
Yep.
or volleyball, okay, basket, okay. So these particular things with respect to what I mentioned, like these tokens will talk to each other. So talking to each other is what is it means, they are having certain relationship between, or relationship based upon the distance, Euclidean distance, and dot products, and certain things will come into the picture, okay. But but the main stuff is like based upon this particular distance, we will be having certain cricket is having say higher probability, and then kabaddi is having say uh, lower probability, volleyball is having say some more probability, yeah, okay. You can take it in this particular way. Then whatever the temperature that I'm going to set, okay, say if the temperature is less, it will restrict to provide the single output. If we are keeping the temperature more towards the higher side, then it will provide more output, and that will be the generic one, okay. And that's what we have seen in in this particular you can say website, the website name was mm-hmm, I Polo Club, okay, okay. So over here, data visualization empower users to visualize. So what we are able to see over here, visualize is having say the 50.67, 54.67 probability, and the temperature set to 0.08. If we reduce the temperature over here, like the create is 19.84, the C is 10.63. Okay, make is 5.01 probability, but if we decrease it, then it will restrict the outcome to the single one only, 19.66. Okay. However, like we are able to see rest of the things, but those are with the less probabilities. Like maximum probability is given to the visualize only. If we move it, then the outcome will be the generic one. But still, like this visualize is having 22.26 probability, with respect to the others. That is towards the higher side, and the word which is having the higher probability, that will be. picked as the next word. So far, what we have discussed about this particular stuff, like, say, we are having certain things in two dimension, then we have added one more feature as royalty. Okay, and then we have represented it in terms of, say, three dimension. Then we try to calculate the distance between the boy and girl and boy and queen. So we are able to see that the distance from the boy to queen is more with respect to the boy and girl. Okay, so with the help of these particular distances, like, I will be able to predict the next word even in this particular 3D dimension model. But in order to represent the 50K vocab size, I need to have the huge dimension, and that particular the meaning in order to have the huge dimension is, like, whatever the token I'm having, that will be represented in that particular dimension. For the GPT-4, I'm having a 12288 dimension, and for the bird, I'm having the 768 dimension. And based upon this particular dimension, I will be able to have the generic outcome. Okay, so major, like, higher the vocab size, definitely I need to have the higher uh, dimension in
dimension.
order to, yes, dimension. And that will provide, you can say, more generic outcome, because, like, I will be able to get the relationship between the words or tokens. Okay, if I'm not having the relationship between two tokens, or the model is not able to establish the relationship, then I will not be able to get the correct outcome. Okay, so I think this is fine. Tomorrow we will see the word embedding, start with from the word embedding, and then the rest of the stuff will be, you can say, covered. Okay, so I think at this moment, like, I'm not, if, like, I'm going to cover the word embedding and the rest of the stuff, then definitely uh, there will be, you will not be able to consume it completely, and that will not be having any use. So I will share this particular link. You try to go through, it's very simple, and probably Swati and others, at this moment you are able to visualize, like, how the things are working, how tokens are talking to each other. You are having a base. We will be having different calculations as well in order to get the exact weight. And we will, our main goal is to calculate, say, if this is the 7 billion model. Okay, 7 billion model. So how this 7 billion number is coming up, so that is also the base with respect to, that we will be able to get with the help of this particular calculation. Okay, so uh, I think, let's conclude over here onto this particular stuff only. And what you need to do, what we will be doing in tomorrow's session, we need to download this llama 2 7 billion hugging face model. Okay, so you need to visit the huggingface.co website, and inside the models you will be able to get this try to download this particular model on your local machine. Okay, so uh, then we will try to do certain tasks onto this particular model, post having this particular model inside our machines. Okay, so previously what we have done, we have utilized the default models, or we have taken the model from the pipeline. Okay, so we have mentioned a particular model, or we have taken the default model, but that is the stuff, like, in order to do the specific task what is there, that is perfectly fine. But it can be done by downloading the model in your machine, and then utilize that particular model in order to perform your task. So what I recommend to all of you, you go onto this particular website, you need to do certain registration and all. Okay, so over here, access user agreement. So once you need to fill your details, it will come like this. Let me try to show. So llama. Okay, so llama 2, llama hyphen 2 hyphen 7 billion hyphen hugging face. This is, you can see, the optimized model. And then it will open, say, llama 2 community license agreement and expand to review. So you need to click over here and it will ask certain details from your side. Okay, you provide the details and submit those particular details. Then you will get the email that like things are approved, and then you will be able to download. You will be getting the download link, and then you need to download this llama model in your machine, and then we will do the practicals onto that particular model, and we will try to have the interactive session in order to do the practicals onto this particular model. So I think that's all from this particular session perspective. In tomorrow's session, just come with this particular model, and then we will cover the rest of things from the transformer internals, like how the weights are being calculated or weights are being prepared. At this moment, we are able to see the relationship. We are able to predict the next word based upon the 3D models or 3D dimensions of the features what we are having. But if we are having more features, so then more dimensions are required. And from the BERT perspective or GPT-4 perspective, we are having, say, 768 and 12288 dimensions. So we will see like how GPT-4 is having 7 billion, you can say, words, 7 billion parameters. So these particular calculations will create the parameters, and mathematics are is also there in order to have those particular parameters. And I will definitely provide you the better understanding, and you will be able to get the things easily. So things are mathematically driven over here, and we will be able to see, we will be able to visualize, like if we are getting the outcome from a gen AI model, generative AI model, then what are the different things happened internally in order to get this particular outcome. And that will be the foundation, that will be your base. Okay, and those particular things will be good from the foundation perspective. Okay, so that's it. If you are having any doubt, you can ask.
E- Yeah, just one question I was having. So, the 50K vocabulary that we are having in GPT-4, correct? And then you
Hmm.
mentioned that we are having some, how many columns can be taken?
How many?
Columns can be taken means how many parameters we can basically give? 12K or how much? 20K.
Dimension is 12288, and from that particular vocabulary and the dimension, we will be having around 70 billion parameters. 70
Oh,
billion parameter model. 70 billion.
70 billion parameters. Okay. Is it
Yes.
because of the limitation? Because if we take the general logical concept, there are 50K vocab, and if we are making the same number of this parameter also, means if the number of row and column will be same, correct? Then we will be
Mhm.
able to capture each and every condition in ideal case.
But you can think it is not limited to one mapping. We will be having, say, festival. Just try to festival,
Yeah.
colorful, and holy.
Yeah.
Okay. Uh, Indian, sorry, Indian colorful festival. Okay, and I'm trying to predict this particular word, holy. Okay, so Indian will be having relationship with colorful than the festival. If like Indian festival and colorful is not, you can say, a club together, if we are not calculating the relationship between with colorful, then we will not be able to predict Holi correctly. So there will be the relationship between these three words, right? It is not
Mm-hmm.
limited to say Indian colorful, or you can say colorful festival. We will be having uh, uh, you can say one more level of calculation, what I can say. Okay, relationship uh, based upon the multiple words, right?
Relationship based upon the multiple words, correct?
Yes. So and that's why like retaining the context is there, and with the help of attention mechanism it will be retained. Okay, so because of that, like the parameter size will keep on increasing. Okay, I will explain like how we are able to get 70 billion parameter. Okay, so so the internals you will be able to get up. So tomorrow we will start with, say, 1 2 2 8 dimension. Okay, I have given you the base, that how the things are happening, like based upon the distance calculation and all. We will be able to predict the next word. We are able to predict queen based upon the certain formula, king man and then woman will be queen. Okay, just simple mathematics we have applied, and we are able to get it. So Euclidean distance is the one thing. Based upon that, like we are able to find the distance between the words, and same thing will be applicable over here. Say the distance from Indian to festival, colorful to festival, and Indian colorful to festival. Okay, so multiple things will come into the picture, and I will quote the example with respect to 1 2 2 8 in tomorrow's session, and then we will be having the better understanding, no? How we will be how we are getting the 70 billion parameters and all. So don't bother about that. Just focus what we have covered so far. Okay, and what is there in your mind, definitely you are able to get. So you can relate this particular session with the first session what we have covered. At that moment, like I have talked, you can say, at the 100 above 100 level, you can say height. Okay, at this moment, like say I'm talking about from the 20 feet above. So soon and soon, as we are going through with more and more sessions, then things, this particular distance will keep on decreasing, and you will be able to relate, you will be able to get the answers. It is not like, say, in the very first session you will be able to get each and everything. Okay, because like if I'm going to explain it at that moment, then definitely you will not able to get. So I have given you the foundation, I have given you the base, and now we are we are digging it, we are exploring it mathematically, like how the things are happening. And at this moment probably you are having a feeling, what I assume, that yes, this is the base, how the Gen AI model is able to predict next word. Okay, I have not given it, but still it is able to predict, and predicting based upon what, the distance at this moment. Right?
Yeah.
Anybody having any doubt, friends? Anything that is there in your mind, with respect to the things what we have covered? Let me ask with me. I think why am I not able to get the name? Please write your name correctly. Raz, Vijay, Abhishek, Neha. Neha is having her first session. Abhishek, Rohit, Swati, Shivam, Tejas, Viranj.
So just one request. Can you just share this today's recording as well as Sunday's recording before EOD? Like this
Yeah, yeah,
session
yeah.
needs a revision before coming to the next session.
Got you, got you. I extremely sorry, Swati. I haven't shared, but yes, I will share it today only.
The today's session also like this will require a revision before coming for the tomorrow's session.
Mm-hmm. Sure, sure. I will share the recordings. Okay.
So first of
So,
all, thank you
mhm.
so much for explaining today's session. It was really a good means overall session. The basic thing was completely clear what you explained. On the operational level, you are telling that we are going to consider it into the next sessions, correct? That how
Yes.
basically the things are being done.
Yeah, so Abhishek and to everyone, like I'm having a way of teaching. Like I try to explain the things. I create a base, and then with respect to the base, I'm moving. Okay, so it will not be good like if I'm going to explain the things that you are not able to consume. Okay, it will not be good. So I have created a base, and the base was created in very first session only. Okay, and now like say we have set the agenda, and with respect to the that particular agenda we are digging it further. Okay, so at this moment like we are able to see that based upon the 3D models or three dimensions we are able to get the distance, and distance is to predict the next word. Okay, so based upon the 12288 dimension, that is the GPT-4. Okay,
Mhm.
so we will dig it further in order to get the understanding like how the 70 billion parameter or 7 billion parameters are being calculated. Okay, no need to worry. Things you will be able to do it with me. You will be able to do it, and you will be able to have the enough understanding about this generative AI. No need to worry.
Understood. Thank you so much.
Okay, so if no more question is there, then we can conclude the session. I will share the recording. Okay, and then tomorrow we will dig it further. And I recommend to everyone to download that particular Llama model in your machine that I have that I have mentioned. Okay, this is the model Llama 2 hyphen 7 billion parameters hugging face. That this particular model you need to download in your machine. Okay, and it is 674 billion parameter. Okay, so download this particular model. We will be having the practical in tomorrow's sessions onto this particular model. Okay. Okay. So take care, guys. Have a good day. Thank you.
Hello.
Thank you so much.